The divide by n counter shown in the below figure initially having Q00, Q11, Q2 0. Okay, for the first clock pulse Z2 K2 becomes Q1 bar, that is Z2 is 0 and K2 is also 0, hence Q2 is not going to be affected, 0 as it is. Here Z1 and so Q2 bar is it becomes 0, Q1 becomes 0, so Q0 J0 Q1 1 0, hence it is going to be 1. Similarly, for the second clock pulse Z2 is 1, K2 is 1, so it is toggles, comes to Q1, Q2, Q bar, Q2 bar, which is, so this is the first clock. If we apply, this is the initial stage. After applying the first clock, this is the sequence. After applying the second clock, this is the sequence. After third, this is, so this is first, second, third, fourth, fifth. Means after fifth clock pulse, the sequence is 100, which is which we are getting for the first clock. Hence the number of different states are 5. Hence it is a marked 5 counter, that is option B is correct. For the single ramp ADC shown below, start conversion pulse is applied. The switch closes for the capacitor to discharge and the counter will reset. The bit sequence Q3, Q2, Q1, Q0 as the counter stop says. Here, as long as VA, suppose if I am indicating this node potential VB, VA is greater than VB, the counter counts. When VA less than or equals to VB, the counter stops counting. Okay, so we have to, VA is 1 volt. Suppose after applying the start conversion pulse, the voltage across the capacitor is I by C into T, so which is, suppose I am indicating with 1 volt. I is 2 milliamps, T is by I, which is 10 into 10 power minus 6, 2 into 10 power minus 3, which is 5 milliseconds. The number of clock pulses applied to the counter decides the how many number of counter counts within this 5 milliseconds. So clock period TCLK is nothing but 1 by FC, which is 0.5 milliseconds. So the count is equals to T by TCLK, which is 10. Hence the count is 1010. Hence option D is correct. See, for the below realization of 5 by 1 marks using 2 by 1 marks, the following functionality table is specified. So we have to find out PQRS take response to. Here the table is given. See, for the 5 by 1 marks, the output equation is written like this. If C3 is equals to 1, means output is nothing but E. If C3 equals to 0 and C2 equals to 0, and C0 equals to 0, then output is equals to C. Output is A. If C3 is equals to 0, and C2 equals to 0, C0 equals to 1, then output is B. If C3 equals to 0, C2 equals to 1, C2 equals to 1, and C1 equals to 0, output is C. If C3 equals to 0, C2 equals to 1, C2 equals to 1, and C1 equals to 1, output is D, means E, A, B, C, D. Hence option C is correct. The H parameter matrix is given in the question. We have to find out the voltage gain for a given circuit. By using Miller's theorem, we can eliminate the feedback resistance. We can replace it towards input side in this way. That is, this resistance is replaced to input side as 200k divided by 1 minus AV, and 200k divided by 1 by AV. Okay, so RL dash is nothing but 200k, because AV is much greater than 1. 200k parallel with 10k, which is 9.52k. So current gain is nothing but minus HFE 1 plus HOE RL dash. Okay, which is minus 50 divided by 1 plus RL dash is 9.52 divided by 40, which is equals to minus 40.3. Okay, and input resistance is equals to, means when we are looking from here, Ri is HIE plus HRE AI RL dash. Okay, if we substitute, HIE is 1.1k, HRE is 2.5 into 10 power minus 4 into minus 40.3, RL dash is 9.52k, which is equals to 1k. Hence the voltage gain is nothing but current gain multiply with RL dash by Ri dash. So current gain is minus 40.3, 9.52 divided by 1, which is nothing but minus 384. Hence option B is correct.